All right, we'll go ahead and get started here. My name is Ryan Frantz. I am a web operations engineer at Etsy. I'm not going to be talking about anything that I'm doing at Etsy because I've only been there 4 months. This is actually a proposal that I sent in to LOPSA before I started working at Etsy, and it's a discussion about the web load balancing solution I implemented with no budget and actually no idea of what the hell I was going to be doing. And I figured I would share some of the design choices that I made, what those ended up resulting in, and some of the lessons learned, such as you don't know what you don't know, and you really don't know until you start really looking at things. And some of the things we didn't know end up forcing some design choices we had to change later on. Don't ask me what the hell that is. I just looked for photos of someone or something carrying buckets of water, and apparently this circa 19th century dancing bear with a top hat came up, and figured, what the hell, why not? All right. So a little background. I had some pain to deal with. I was working at a company where we were hosting 60 or more websites, and all of it was on a single server. Now that server had some beef to it. It had redundant disk, a nice little RAID array with a couple hot spares, N+1 power. Everything's great, but the only thing that's not redundant there is the motherboard, right? We needed to scale horizontally. So we had a single point of failure, and because of that, we had extremely inconvenient maintenance windows. So for our clients, they're trying to run their business, and we can't keep going to them and say, hey, every month at this time, we need to take the system down. Can you change your processes around our maintenance? Especially, in the 2000s now, we should be able to do some of these things transparently. It's also especially inconvenient for my team because they would have to be doing work, well after hours or early on Saturday or Sunday mornings, and really, no one wants to do that unless they have to. So generally, the stack looked like this. We were running VMware ESXi on all the systems, and I'll go into a little more a discussion about what the layout of the system looked like. But we had our load balancers and our web servers that we're building out. We decided to put ESXi in all of them because we're trying to future-proof the design. We were hoping that we would be able to demonstrate to upper management the benefits of being able to virtualize our systems, and then we could actually get some budgeting in place for using some of the pay-for tools such as vMotion, right? So that we could easily lift our VMs, move them somewhere else. The idea is that we actually want to we wanted to co-locate at some point, and wanted to make it as easy as possible to do that. At the time, everything was on premise. We used CentOS for the load balancers, and the load balancers themselves were running nginx for SSL termination, haproxy to actually do the load balancing of the websites, and then keepalived was used to actually provide redundancy between the load balancers. And if anyone's familiar with the virtual router redundancy protocol, keepalived implements that for you on a server level, so that there's a heartbeat between two instances, and one instance says I'm the master for this address, the other instance says I'm the backup. And if the heartbeat fails for whatever reason, the guy that's the backup will say I own this address, all right? And then the system's trying to access or trying to hit that address. Basically, they don't see any disruption. What we decided to do with keepalived is actually split all of the addresses in our IP range across both load balancers to create what was in effect an active-active situation, but it was mostly because we didn't have any other solution to make that happen. All right, here's just a very simple diagram of what the load balancers look like. So we had two load balancers that we built running CentOS. nginx was there solely for the SSL termination. haproxy did all the heavy lifting and knew about the back-end web systems, which happened to be running Windows 2008 at the time and IIS. This is actually an interesting experiment because the shop I was working was primarily Windows-based. The application was developed in .NET. So there were some folks a little bit scared until I demonstrated that it doesn't matter what you're using in your environment as long as it meets certain needs. In this case, it's HTTP and HTTPS. Who cares what's doing the work, right? Both nginx and haproxy on both the load balancers actually had the exact same configuration. You're probably thinking to yourself, well, how the hell does that work? It was absolutely necessary to do that in the event that one of these load balancers took a hit, the other load balancer could pick up, and there wouldn't be any issue whatsoever with it starting to fulfill requests. keepalived D almost shared the exact same configuration, but on load balancer 1, it would say half of the IP addresses I'm master, and the other half on backup, and vice versa on the second load balancer. And again, just IIS down here on the bottom. So I don't want to get too caught up in a lot of details, but I did at least want to demonstrate some of the configuration design choices that we made. So I've got a couple pared down configs. There's some things I wanted to highlight about the way these systems were configured. And I wanted to start with a little bit of sys control output, basically kernel tuning, if you guys are familiar with that. Some of the decisions we made here were based on the design choices we made. Some of the settings we added here were based on things we learned after we actually implemented the load balancing stack. So the very first item here, setting IP non-local bind equals 1, was absolutely necessary so that the two load balancers could actually fail over for each other. Remember, I stated that both nginx and haproxy had, or both load balancers had identical nginx and haproxy configs on both sides. The only way that actually works, I'll back up a second. If you try to start a service on a Linux system that binds to an IP address, and an IP address does not exist for a given interface, the service won't start. It can't bind to it, right? This little handy kernel tune here actually lets the kernel be a little looser about it. Right, it's okay, I know that IP address is in there. Maybe it will show up one time. I'm going to let you believe that you're binding service. I'm going to make you, let you believe that you're binding to this interface. If that address comes up, great. Well, we're off to the races. So this was absolutely required for the configuration that we had in place. The rest of these tunables were required because we started seeing issues with throughput in the load balancers. For example, when we started to exhaust in our tests, we started to exhaust TCP sockets. Okay, so what we had determined was we had a large number of sockets in a time wait state. So we told the kernel, go ahead and reap those basically if we start to run out. We needed a lot more available sockets on the system. The default for the kernel is about 20 or 30,000 available sockets. Well, because we had so many sockets in time wait state, this is actually where we went first. Like, let's just open it up. More sockets, right? Invite more people to the party. Then we found that we also had a lot of sockets that were stuck in the finished state. So we said, let's just shrink the timeout for sockets in the fin state to 30 seconds, right? They're done, right? And if you're familiar with, because everyone here is familiar with TCP, right? So the idea is that even though the socket might be closed, the kernel believes that even though we've broken up, like, he's going to call me again, right? That socket, that connection is going to come back, and I'm going to be there and welcome him with open arms. And so the kernel will leave packets in that fin state for a while longer, thinking that it'll be able to reconnect a connection that comes back because it's less expensive to do that than fire up a new set of connections. We also found, because we were running IP tables on these load balancers. We're all running some sort of firewall right at the edge, hopefully on the host as well. Defense and deaf people. I don't remember if this is actually a necessity or when we started bumping sockets, we said, shit, we've got nearly 65,000 sockets open. Let's just bump IP tables, connection tracking slots to twice as many and then just not worry about it. I wish I could remember what we did there. This is a while ago. And then similar to the fin timeout, anything that was in the time wait state, those sockets normally don't close for a total of 2 minutes, and that was just way too long when we're firing a lot of connections on our load balancer. So we dropped that down to 30, and I think even that might be too high. Here's the nginx config, and I pared these configs down to show mostly just the relevant bits that matter to us. There is a global block up here that within that you can define your upstream and server configs. The upstream statement in nginx simply says this is like an endpoint or a destination for nginx to send traffic into, and it's extremely important if you're going to use nginx to proxy traffic, as we were, because nginx's sole purpose in life in this solution was just to terminate SSL traffic. If we didn't do it this way, we'd have to have our SSL keys on every single node or web host behind the load balancers, and that becomes a management nightmare. And it's easier just to only have to manage your keys in one, maybe two places, which we did with the load balancers. So its only purpose in life is just to send packets, send requests into haproxy. Nginx and haproxy are running on the same box, so you'll see here in this instance, IP address 192.168.1.2 is actually an address on the load balancer's interface. So in the server block, I basically tell nginx, listen on port 443, here set up my SSL config, match all my requests, and send them to this upstream host. It's pretty simple. All right, you can do a lot of fancy things with nginx. It's pretty fast. We actually used it for, it's got a handy feature that you can match certain requests, all requests, and say if given other conditions such as there's a state file somewhere on the system, you could then redirect the requests to a static page. And we use that for the purposes of notifying clients that we're in a maintenance period or we're having an issue. So if we had an unplanned outage, we could pretty much just touch a file, and for a given site or globally, nginx would say that file exists. Here, send them over to this happy little 4 page, a la GitHub with its cool little AutoCAD. Yeah.
If you were going to put multiple domains behind this load balancer, would you put an upstream?
Yeah, you'd have multiple upstream and server blocks for each, basically each virtual host that you're in Apache parlance. But yeah, for every website that you're going to have nginx sitting in front of, right? Now onto the haproxy stuff. There's a lot going on here, and believe it or not, I trimmed even more just to get this damn thing to fit on the page. The one thing that I wanted to stress about haproxy, it's a pretty robust solution, but when you've not touched it before, the documentation for haproxy, while very dense, was not always clear or seemed to be complete. A lot of these settings that ended up in the config came as a result of testing. And I don't mean just testing like, does my application work? I mean doing some sort of figuring out what's important for you to stress the box, whether it's getting some synthetic testing software to just hammer the system with requests, pulling plugs to see how the thing behaves when the other load balancer isn't responding. And in particular, I initially thought that the retries and timeout connect statements here actually were the meat of haproxy, determined whether or not it was supposed to handle a request or send a request to a given backend. Turns out, because haproxy does have the notion of health checks, which I'll talk about in a moment, turns out that really haproxy, all it does with retries and timeout connects is that it's kind of like a lightweight health check. If haproxy is trying to send a request to a back-end system and it tries twice and within 2 seconds for each of those it can't hit it, then it says, I'm going to move on to the next back-end system. Even though haproxy down here might say, well, I know it's alive because my health check has passed. It might just be that your health check is shit. Maybe you need to tweak that. So a lot of testing a lot of testing resulted in basically the combination of these two, the retries statements and the health check. You want to ask a question? No. Oh, okay, sorry. There were some other timeout functions here. There's one I wanted to highlight in general, and that's the timeout server statement. You see it says 15 seconds there. I just want to back up real quick. You'll notice in the, showing all my slides, showing all the good stuff. Up in the nginx config, there's a proxy read timeout value, and that's set to 1500 seconds. You're like, holy shit, that's a long time. That's 25 minutes, right? That's, in terms of web applications, that is a lifetime. But there was a good reason behind that, and it's called the business, right? The developers had written a couple long-running reports that when a user decided to, and they're ad hoc reports, which made them even more interesting, a user could submit a request to generate a report, and the page would go off and start building the report, but it would never come back to the browser and say, you know what, this is going to take longer than I expected. You know, listen to some on-hold music while we go and generate that. We'll send you an email when it's done. It would actually sit there and churn. So when we first rolled out the load balancing solution in production, that was one thing we hadn't tested for. We actually didn't know about that. So what was also fun about this was that we got to learn more about the applications. We interfaced even more with the developers as a result. And they said, oh yeah, that thing runs 25 minutes. As if that was a normal thing. That was an expected thing. And so we tried to work with them to improve that. But the reality of the situation is the business required other things. Other things were prioritized. So we had to make a concession. And luckily there is an option in both nginx and haproxy to say, hey, if that back end or this upstream system, it doesn't respond in a certain period of time, we're going to close the connection, but you can also give it very, very, very loose timeouts. All right, so that's one thing to keep in mind. I hope none of you have to deal with that, but know that you can adjust to that if you need to. A couple other options real quick I want to touch on. The option forward for was very important because if you're going to be parsing your logs on the web backends, if you don't have this set, then all of your requests look like they came from the load balancers. If you're trying to do any sort of analytics on website utilization, where do people come from geographically, or who are my heaviest users by IP, you won't be able to because it'll look like your load balancers are the only consumers of your application. This will insert the IP address that the load balancers actually fulfill the request on behalf of. And then option HTTP close, I don't know how often it's used in other implementations, but I made a choice to implement that because I love logs. And haproxy by default, if you don't, it doesn't have option HTTP close enabled. And what happens when it's not enabled is that the first time a connection is seen, haproxy logs it and then just ignores it. It handles it, but you don't see anything else in the logs. And the downside of that is when something goes wrong. haproxy's got extremely dense logging, and it'll tell you every single thing about the connection that you might need to know. How long did it take between the client and the server? How long did it take between the server being haproxy? How long did it take between haproxy and the backend? How many times did it attempt this? There's a lot of information in those logs, but you miss that unless you set option HTTP close. The downside of that is that after every HTTP connection, haproxy closes it. So you're constantly opening and closing these sockets, and you'll understand why I had to increase I had to do some kernel tuning to increase the number of available sockets, to decrease how long these sockets lived, because I had to make some trade-offs between functionality and actually being able to manage a system when things go wrong. And then finally, in the haproxy listen block, this is where you define your website, just like you would in nginx. You can have one or more listen blocks. Pretty much everything after the listen statement is assumed to be part of the website definition until the very next listen statement. And it's here in the server statements that you define all of your backends. We decided we needed to track a cookie. We just call it server ID. We set that here in the cookie substatement. We weighted everything. This is more for tracking. So again, if things went wrong, we know where did that request came from. It came from trip dub 1, trip dub 2, whatever. We weighted them evenly. You see we're using the round robin algorithm to balance. So every new request that came in just went to the next web backend. We have a check interval of 1 second. So this relates directly to the option HTTP check statement. So every second, haproxy is sending a single request to all three of these backends saying, just show me that HTML file. If it exists, I know that you're alive. Okay, and you can do a number of different things. You can do ping and maybe there might be one other option, but ping seems pretty useless to me. If a system's coming up and I can ping it, but Apache or IIS hasn't started up, there's no point in considering that host alive because I can't actually send it any requests and have them be fulfilled. Then finally, in the server statement, there are fall and rise substatements. Fall basically means if haproxy sees 3 consecutive failed health checks, it will mark that host is down, basically pulls it out of the pool of backends. And rise 2 is if I've seen 2 consecutive health checks return after it's been in a down state, I'm going to start sending requests to it. All right. Any questions? I know there's a lot of stuff here. It's pretty dense.
Yeah, what other balance options are there besides the round robin?
There is least connection, and I believe a third one. It has been some time since I worked on this. I don't remember. The haproxy documentation will tell you. We tested round robin and least connection and didn't really see a whole lot of value in least connection because, to be honest, our load wasn't that high. That was another interesting thing about this project, which I'll touch on a little bit later on. We had no idea what to expect. We didn't know where to start. Should we go round robin? Should we go least connection? Something else? What's going to work for us? We just had to test the hell out of it. And it turned out that we got no benefit out of least connection because the load just wasn't so great. So we just said, let's go round robin because that's a little more obvious for us at the moment. So some of these design choices aren't really based on a whole lot of information, just enough, right? It doesn't work for us, or gives us no benefit. Let's go with something that we're more comfortable with, that we understand right now. And if we ever needed to, we could change that. Any other questions on this? Yeah.
For going back to the servers, I know you can use haproxy with like Tomcat and stuff.
Mm-hmm.
Can you also specify which port it's going to? If, say, for example, since you know on Tomcat you can only use really up to like 3 gigs of RAM before it just is not utilizing it right. Can you specify which port it's going to and not just
For the back ends?
Yeah.
Yeah, in the server declaration here, you could specify alternate ports. It's without it, it's just an implied port 80. All right. And then finally, the keepalived config. Keepalived is it was handy for us because it let us actually create redundant load balancers. Again, we split all the IP address that we managed into 2. We said you're getting half. And you're getting half. And we didn't really do that in a completely sane way, unfortunately. What we did, because we didn't have, it's not like we had all of our websites started at address 1 to 50. They, over the period of many years, people just randomly picked addresses out of a block of 254 and assigned them to the DNS records for the websites. So what we did is we kind of took advantage of keepalived's requirement, which is a little bit weird, I think, that you can only define 20 addresses per VRRP instance. I'm not really sure why that's a limitation. Why you can't just say here's all 255 or 254 addresses, or the only 3 that I care about, or whatever. You're limited to specifying 20. So what we did, we said let's take our whole DMZ subnet and just break it into as many groups of 20 as we can, and then we just alternated. We had multiple blocks of 20 addresses, and we said for group 1, well, on load balancer 1, you're master. On load balancer 2, group 1, you're backup. And we just sort of alternated back and forth. And that actually manifested itself in an interesting way, which I'll show you when we get to some of the graphs where we're monitoring connections. We didn't know what to expect. We just thought that was reasonable at the time. We're splitting it in the config, but we don't actually know if we're balancing all of our websites across. We have 50% of our websites on one load balancer and 50 on the other. We're just doing the split through the config. And as it turned out, we actually, obviously, it's obvious now, hindsight's 2020, we weren't really balancing our sites across the 2 load balancers as evenly as we thought we had. So the meat of the keepalived config is right here in the VRRP instance statement. You define the interface you're binding on. This is the advertisement interval. This is how often the heartbeat for keepalived checks in with the other instance. The ID is important. It can be an integer between 1 and 255. The other load balancer has a unique ID. It doesn't matter what it is. It could be 1, it could be 2, or anything up to 255 if need be. Then you set the priority, and I'm not very clear on why you set a priority when you're already telling keepalived I'm the master. I think you might be able to have. No, I'm not going to say that. Never mind. I don't remember why there is a priority value here when you state that this instance of keepalived is a master. Now I have to look that up after this presentation. And then, if you want, there is an optional authentication block here, which we were encrypting the heartbeat because it's not a good thing if something comes up on your network and says, don't listen to this MAC address. I really own this MAC address, and all of a sudden you got a man in the middle type issue. This worked pretty well for us for a period of time until we upgraded the instance of keepalived on our load balancers at one point. We started to see sync issues where there's a little bit of drift that keepalived allows for between the two instances. It'll let, because it'll actually increment in the heartbeat, there is a value that will increment for each subsequent advertisement. So the first time it goes out, it says advertisement 1, and it gets a response back. And then it's okay, advertisement 2, and it keeps track of that value and constantly increments it. And I don't remember what the drift is, but it'll let a couple of heartbeat packets, kind of slip or take a little longer to come in before it actually says, alert, I'm going to start taking all these addresses. What we found is keepalived was starting to get way out of sync, and even though both of the load balancers were online, one would flip a switch and say, I own all these IP addresses, start throwing out gratuitous ARPs over the network, and then start receiving traffic. In some cases, the switches got confused and didn't know where the hell to send the packets to begin with, so we got no traffic going to some number of our websites. And that was definitely a bad thing. Anywhere between 10 and 50%, when this happened, 10 and 50% of our websites were unavailable until we simply just restarted keepalived on both instances. We tracked that issue down to a bug in the authentication code, and there was no fix on the horizon. So design choice here, we recognize that this heartbeat's going across a secured, physically secured DMZ network. It's okay to turn off authentication, but that's an acceptable trade-off for us based on what our network looked like. So we did, and then we never had sync issues again. That maybe have been fixed by now. This was probably over a year ago, but at the time, we just turned it off. So a couple pitfalls, right? Some things that we learned, and I definitely wanted to share these with you, is VMware likes to turn on a feature called TCP segmentation offload. What that does for normal traffic, what people are most accustomed to is that the size of a packet is 1,500 bytes, roughly. TSO will make its own mind up about how big the packet should be, and it'll send jumbo frames if need be, because it's actually offloading that responsibility from the CPU and sending to the NIC. The NIC says, hey, I can handle jumbo frames, and I'm pretty certain that the endpoint I'm going to talk to can handle jumbo frames, so I'll send them along. This works really well when you've got two VMs that are sharing a virtual network, because they never actually go out on the wire. But what I found is that all of a sudden my websites would just go offline. I'd start getting 500 errors in the browser. The host would be up. I could actually hit the web page when I was on a web host locally. So I knew there wasn't a problem with the NIC itself or the operation of the web server. And things like TCP dump and Wireshark weren't showing me what was happening. Well, that's because they don't actually always, those tools don't always see the packet at which level was it? I think it's all the way down at layer 2, I think it was. I don't remember, but there was an issue where the tools that I depended on weren't helping me because they couldn't see that far down into the operation of the network. And the funny thing is, I had written a blog post about this like a year before we ran into this issue, but I forgot what these symptoms look like. And it's always an amazing thing when one of the guys that works for you pretty much just sends a link to you, and it's your blog post saying, yeah, boss, here's a fix, right? It's pretty humbling. I'm like, yay, someone read my blog. But I guess I should have remembered this, right? So if you're curious about TSO, go check out my blog, and hopefully that won't happen to you. We disabled TSO. We didn't need it. We didn't need to offload TCP segmentation. It might be useful for some people, and actually I'm certain it is, but our network was not ready for jumbo frames. It wasn't built for jumbo frames. It was expecting to see the maximum transmission unit of 1,500 bytes and change. I forget the exact value. So we disabled it, and everything's fine. We never saw that again. So if you're using VMware, and actually if you're using any sort of virtualization, you might want to look out for that. It's pretty easy to disable. In Windows, it's actually on by default. You just go into the NIC properties. Even though I think specifically we were using the VMXNet 3 interface driver in VMware, so look out for that. So the really interesting stuff is after you got this thing working, now what? What do you know about the operation of this environment? Well, I can get to the website, right? Everyone's happy. But things break. You grow. You need to know what's happening within your environment. And to be honest, I had no visibility into the performance of these systems. I designed them as best as I knew at the time, and in fact, I had told upper management, I'm going to build you a load balancing solution. I really don't know how I'm going to do it, but I'm going to build it, and it's going to work. I did a lot of testing, put a lot of man hours into it, myself and the rest of my team. But the reality of the situation at the time is I also had a small team, and we only had so many cycles to do things, so I had to make some sacrifices around the time I spent into designing the solution and actually trying to monitor. So of course we had basic monitors like Nagios, making sure the hosts were up, making sure the services were running, the basic up-down stuff. But we didn't have any visibility into the performance of the systems. Just how many requests are we getting, how many TCP connections are there, is IP tables behaving. So and even beyond that, do we experience any sort of seasonality, such as the typical 8 to 5, or maybe there's a 24-hour cycle where you're seeing activity kind of due to the valley and the hills and valley type pattern. We didn't know that, so we started working with the tools that we had. I had NTOP in place that was pulling information, pulling data from various network taps that we had in the network, and just based on that really rough data collection, I found that we had seasonality of 6 to 6 a.m. Eastern to 6 p.m. Eastern, and I'll demonstrate that here in a couple graphs. And then when we started getting some clients on the West Coast, I'd go back to that and see that we're actually extending that a little bit more into 8 p.m., which I thought was kind of interesting. Like the people on the West Coast, our clients at 5 p.m. their time, they bailed. I mean, they were out, which is kind of neat because we weren't that far off in terms of scheduling our maintenance windows to be after hours. There wasn't that much load. But the interesting thing is, at least for me at the time, I didn't know that. I didn't know what I didn't know. But once I started graphing the activity, I could make informed decisions. Then there were also issues with respect to health, like I referenced keepalived. Well, how do you figure that out? Well, what we found is parsing through the logs, because again, I love logs. Parsing through the logs, we would actually start to see some behavior, some entries, such as the sync between the two instances of keepalived were starting to drift too far. And so we could then monitor for the number of instances in the logs, and if we saw that, we could be proactive. And even though it sucked at the time, we'd just say, let's just restart keepalived. We might have a hiccup for a second, but we'll be okay after that. And then eventually, as I said, we turned it off. So the main lesson that I wanted to share here is you just got to start graphing. You got to start collecting information. It doesn't matter what it is. Graph what you know, because when you start looking at what you are graphing, you ask a question. And when you start asking questions, you start graphing and collecting more, right? And you learn more and you ask more questions, and then it's almost a foregone conclusion. I should have done this a long time ago. And I don't care what tools you use, whether it's graphite, whether it's some that maybe some people in this room would like you to use. Graphite, Nagios, Ganglia, use them all. Cacti. It doesn't matter, whatever suits your needs. And they know that there are even tools that layer on top of that. There's a lot of tools that layer on top of graphite. I'm a big graphite fan because it's so easy to use. But use them, start asking questions, because you'll get even better at it. So I want to share just like a few graphs. These are some of the initial ones that I thought were really important. Turns out they weren't. And I'll share a quick side note. Because I was interfacing a lot more with the developers, I'd go to them and say, well, what do you know? What is important to you about these applications? And 9 times out of 10, the developer is going to have more business information than you, because they're the ones fielding the requests. They're the ones in those meetings say, hey, we'd like to do this great thing with the application. So they're getting a lot of that business information that could be useful. And so it's always important to be talking to them. And in this case, they said, well, we can tell you when people log in. I thought, oh, that might be useful, because maybe I could say in the last hour, 20 people have logged in. Turns out there really wasn't. When I sat down and asked the next question, well, is that really useful? Turns out it wasn't. Who gives a shit how many people logged in, unless you can tie that to some sort of business value, right? In our case, we were running web applications for nurses and hospitals that would check in and check on the status of patients. They would use it to complete protocols for patients that they were managing. So lots of times they would just log in, they'd look at something, they'd walk away. Or they might add a note that might take 10 minutes to write and then save it. So there wasn't a whole lot of constant activity. So knowing how many users logged in at a given period of time didn't really help. I mean, it was interesting to know that most people logged in the morning, as is usually the case. But other than that, it meant nothing to me. It meant nothing to the business. So at first I thought this might be good to know. I've got metrics here for one load balancer, and this is just a breakdown of the get and post requests. As one would expect, there's a lot more get than post requests, but you can actually see the seasonality here. You can see a little bit of a dip right there around lunchtime, but a whole bunch right there in the morning. Everyone's logging in. I'm working, boss, right? And then things kind of trail off at the end of the day. That's great. Well, let's see what happens with both load balancers. Well, they both follow that same pattern. These the blue and the red here are get requests, and they follow that same seasonality. Notice, however, the only thing that's really useful to me here is that I know that this load balancer is taking more requests than this load balancer. So knowing how many get requests, probably not too useful, but I do see a pattern here, something I suspected when I configured keepalived, but now I know the load balancer, the distribution of websites across the load balancers is not as even as I thought it to be, or I wanted it to be. All right, great, let's extend this out. Let's look at both these load balancers for a week. Well, we see that same seasonality, the same pattern, day after day after, whoa. Everybody really is working for the weekend, right? We're out having a party. We're not going to be logging in, no. So again, this just, while it kind of sucked to make the statement that yes, it really is okay to have scheduled maintenance on the weekend. For my sysadmins, it was horrible, but for our clients, we could say with some degree of certainty that there was less risk to them, which they like to hear, of us doing maintenance over a weekend, because the data showed that there wasn't a whole lot of activity. And so giving folks some advance notice, they were going to be doing some work, was a lot better than surprising them. Now, of course, since we had a load balancing solution in place and we had scaled our web servers horizontally, we could do that transparently, especially in an emergency.
If you had it set for round robin and it should be alternating, why would the amount of requests be so different?
Because the IP address space, we weren't actually saying I've got 10 addresses. I've got 10 total addresses. I'm going to take 5 of them, put them over here, and 5 put over here. Our address space extended across a complete 254 address space, and we just said, okay, take those 20 and define them in this interface. And so there might be like 3 or 4 of those addresses actually active, and the next block had nothing. So it wasn't actually evenly distributed. What would have made more sense is if we actually said we had configured keepalived that way, because we thought, oh yeah, we're going to keep growing, and the addresses will already be there. All we have to do is just fire up a website, and we don't have to change keepalived. When in retrospect, what we should have done is said, these are the actual IP addresses that are active for our domain records, and let's just actually explicitly define those and then break them out evenly. We didn't do that. We started then monitoring TCP connections too, because we started to see socket exhaustion. We want to see, well, what's going on? We see at any given point in time, we've got close to like 300 established connections. That's heavy right there. It's pretty heavy. The interesting thing about this is we realized we didn't actually have that many people using our websites. We had thousands and thousands of user accounts, but it only looked like there were a handful of people using it at a given time. This doesn't translate to users by any means. It's not 300 users, it's just 300 TCP connections. Could have been 100 users, could have been 3 doing a lot of work. All right, but again, this wasn't entirely useful in the long run, but at least it told us something about what was happening. Even more importantly, this is a graph of established connections, connections in closed wait state, and those in the closed state. Kind of interesting. What's really interesting is this one. Those same data points that you showed you are way down here. This one, it's the number of sockets in the time wait state. So at any given point in time, we had nearly 7,000 sockets doing jack. We went all the way up to close to 10,000 at one point. It's wasted processing. So we recognize there were some limitations in our design, but we didn't know that until we started monitoring. So if I were to, in addition to this, part of the reason we had so many sockets in the time wait state was because we had so many health checks. Remember, haproxy was sending a health check every second to all three of the back ends. We had Nagios checks hitting it externally. We also had the connection from the user to nginx, nginx to haproxy to the back end. So these things just started to accrue pretty quickly. So basically, the two things that I wanted to share with you guys, as I'll wrap up here, we've got a couple more minutes, is not so much what the design was, but why we made those design choices. And then you just got to monitor. You've got to start collecting information, understanding what it means, ask questions about it, because we were then able to make some additional design changes, tuning the kernel, for example, trying to improve the situation, but you can't do that without relevant information. And sometimes that relevant information is, that metric doesn't mean shit. It means absolutely nothing to me. I got it now, it might be useful in the future if something goes wrong, but it has no relevance at the moment to what it is I'm trying to accomplish. And that's also a valid statement to make as well. And then finally, the good folks at LOPSA, they want your feedback. So take the survey. If you've taken any training sessions, definitely fill it out. If you found them useful, didn't find them useful, you're somewhere in between. And then rate the conference as a whole as well. Now, I don't think there was any evaluation for talks. This is my first talk, so I would appreciate it if you hold the applause and well-wishing and we think you're awesome, and tell me what stunk, what was clumsy, what worked, what didn't work, because I'd like to get better at doing this. I like to share what I've learned. And finally, if you got any questions, watch out, this guy's scary. You can find me on Twitter. I work at Etsy. You can email me there. I share as much code as I can on GitHub, and of course, you can check out my blog, ryanfrantz.com. And that's it. Any questions? Shoot.
Can we get your slideshow?
Yeah, I'll put it up. I have to find Adam Moskowitz because I think I promised him, but I actually give him my deck last night, and I didn't. But I'll get it up. I'll throw it up on GitHub too.
Okay.
Right? Yeah.
There's nothing different with like the haproxy configs that you're doing that, like if you were to use Apache instead of IIS, right?
Correct. Yeah, it's completely agnostic what's on the back end. Also note that I believe in October of last year, haproxy started to support SSL.
Okay.
So that would obviate the need for nginx if you want. At the time, it was still experimental, but it would take one moving part out of the equation. Yeah.
So knowing what you know today, and the path that you've gone through, and the way the tools have evolved since then, could you consider a different stack choice of building this, or would you go this route again?
I went this route. I didn't really touch on this, even though the deck is titled Web Load Balancing on a Budget. I knew I didn't have any money or any will from upper management to go out and purchase an F5, for example. But on the flip side, I couldn't tell them that an F5 or an A10 was appropriate. I didn't have any information. I didn't know what I didn't know, so I couldn't go in front of them and say, I need a couple grand to have something sit and collect dust because we're not actually passing that many requests. The biggest takeaway from me is now I know better what to profile so that I can define the appropriate solution, or it's close to appropriate. So this I did the best with what I had and what I knew at the time. Yeah, it's a good question. Anybody else? Do you have one? Okay. Anybody else? Okay, cool. Yeah.
So with the disabling TSO,
Mm-hmm.
what was the symptom that made you first suspect TSO? Like, I mean, how did you get to?
I didn't. That's an excellent question. I had no idea. I got to a point where I exhausted all of my abilities, knowledge of all the tools I had to try to troubleshoot the issue. I was trying to think creatively, some way to maybe indirectly find the cause, and I couldn't. So I radioed a friend, And he was a guy that I've been able to rely on for a really long time. He was actually a mentor of mine at some point. And I just asked him, like, have you ever seen behavior like this, these sorts of symptoms? He said, yeah, 6 weeks ago. It's TSO. Check it out. I got lucky, honestly. Yeah. It's good. I'm really happy to see everyone here. I knew one person was coming, so that, this is very validating, guys. I appreciate that you stopped by. Feel free to hit me up, email me, whatever. I'd be more than willing to talk to you about this or anything else. All right. Thanks, guys.